In software development, we're constantly naming things variables, functions, classes, the list goes on and on. And because we do it all the time, we really, really need to do it well. So today, we're going to dig into how to write code that basically speaks for itself, all by harnessing the power of meaningful names.
All right, so take a look at this little piece of code. On the surface, it seems pretty simple, right? There's no crazy algorithm, just a basic loop, a list. But can you honestly tell me what it does?
Really think about it. What kind of things are even in the list? What in the world is the significance of the first element of X? And what's with the magic number 4? If you're scratching your head right now, don't worry, you're not alone. The problem here isn't that the code is complex. It's that its purpose, its context, is totally invisible to us. And that leads us straight to the big idea for today. The names you choose in your code should scream their intent. The whole goal is to make your code so obvious, so explicit that anybody, and that includes you 6 months from now, can understand it with just a quick glance. This slide right here, this sums up the entire philosophy perfectly. On the left, you've got the variable d. It's so vague it actually needs a comment to explain what it is. But on the right, elapsed time in days is crystal clear all by itself. So here's the key takeaway. If a name needs a comment to explain it, the name has already failed. Simple as that. Okay, let's jump back to our mystery function. What if I told you this code is for a game of Minesweeper? Suddenly we can start adding some real context. The list, that's actually the game board. Each item, X, that's a cell. And that magic number 4, well, that's just the status for a flagged cell. Look at that. Just by renaming a few things, the code is already starting to tell us a story. But wait, we can take this one step further. Instead of this kind of vague integer array representing a cell, what if we created a proper cell class? Now the code gets even simpler. We can just ask the cell directly, cell.isFlagged. See what happened? All those messy implementation details are now hidden away, and the code reads just like a simple sentence. That, my friends, is the power of combining good names with good design. So we've seen what good naming looks like. It's clean, it's clear. But to truly master this, we also have to understand what not to do. So let's dive into some of the most common naming traps that can make our code an absolute mess. We're going to focus on 4 major pitfalls here. First, leaving false clues, which is just disinformation. Then there's making meaningless distinctions, using empty noise words that don't add any value, and my personal favorite to warn people about, using cute names.
First up, disinformation. Just look at this. Is that a capital O and a lowercase l, or maybe it's a 0 and a 1? Who knows? The font you're using could completely change what you see. Using names that look like other characters is just a recipe for disaster. Please, don't do it.
Next trap, meaningless distinctions. Okay, picture this. You need to get an active account. You start typing and your autocomplete pops up with these 3 options. Which one do you call? What's the actual difference between them? Words like info and data are often just noise. If you're going to make names different, make sure that difference communicates a real, meaningful change in what they do. And finally, the cute name. Look, I get it. Calling a function holy hand grenade might get a chuckle from your teammate today. But what about the developer who has to maintain this code a year from now? Are they going to get the joke? Probably not. They're just going to be confused. So always choose clarity over entertainment. Just call it delete items.
All right, so we know the traps to avoid, but what should we actively do? Let's get super practical with a simple checklist you can use for creating great names every single time.
It honestly boils down to 3 simple rules. 1, make your names pronounceable so you can actually talk about them. 2, make them searchable so you can find them later. And 3, make them consistent so your code doesn't feel random and unpredictable. So rule 1, make it pronounceable. Why? Because programming is a social activity. We have to talk about our code. The source material tells this great little story about a variable named GenUDMHS. It stood for generation year, month, day, hour, minute, second. The team literally couldn't say it, so they just started calling it GenUMutahems so they could even have a conversation about it. And here's the fix. Instead of a class called d2rcrd102 with a variable that sounds like gibberish, we refactor it. We create a customer class with a generation timestamp field. Now you can have an intelligent conversation. Hey, I think the generation timestamp on this customer is off. It's clear, it's simple, it's professional. Rule number 2, make your names searchable. Just look at the code on the left. Imagine you need to find every place that the number 34 is used for this specific purpose. How would you even search for that? It would be an absolute nightmare. But on the right, by using a named constant like number_tasks, you can search for that exact term and find it every single time. Easy. And rule 3, be consistent. This is a huge one. If one class uses get to fetch data, please don't let another class use retrieve and a third use fetch for the exact same concept. Pick one word for one idea and just stick with it everywhere. Consistency makes your code base predictable, and that makes it way easier for everyone on the team to understand. Okay, so we've covered the principles, we know the rules, we know what to avoid. Now for the fun part. Let's put it all together and watch how these ideas can completely transform a real piece of code. So let's look at this function, print guess statistics. The variables here, number, verb, plural modifier, they're not terrible on their own, but the problem is you have to read the entire function just to figure out how they all work together. They're just kind of floating around, missing a shared context. And the solution, as the slide lays out, is to give them that meaningful context. Instead of having all these loose variables swimming around inside one big function, we can group them together where they logically belong, inside a new, well-named class. And voila! Here's the result. We've created a new class called guessStatisticsMessage specifically to hold these related variables. Now their context is crystal clear. And as an awesome side effect, this refactoring let us break that original, big function down into smaller, much simpler methods. The code isn't just a little cleaner, it's fundamentally easier to reason about. Which really brings us to our final and maybe most important takeaway. Listen, anyone can write code that a computer understands. That's the easy part. It takes real skill, real professionalism to write code that humans can understand. As the source material puts it so well, a professional programmer knows that clarity is king. So I'm going to leave you with a little challenge. Go look at the code you're working on right now. Find one name, just one, that you can improve today. Take 5 minutes, make that one small change, and start the habit of making your code speak for itself.